Hey guys, this is Miss C here. Hope you guys are doing okay. I am going to go over the Unit 2 test review and go over some of the harder problems on this worksheet. And any problems that I don't go over on here or that you want more explanation over, feel free to ask during class tomorrow since the test opens up at 1:30. So we are going to start with 1C. So this problem might look a little different. So the directions for one is solve the following equations and inequalities for x. So in this problem we are given two fractions where we have 2x plus 4 over 3 equals x plus 3 over 7. So the best way to solve problems like this is by a method called cross multiplication. And so what you're going to do is the diagonals are going to multiply together. So 2x plus 4 is going to multiply with 7, and 3 is going to multiply with x plus 3. Okay, and so I'm going to rewrite this as 7 times 2x plus 4 is equal to 3 times x plus 3. And when I simplify that, I'm going to get 14x plus 28 equals 3x plus 9. And I feel pretty confident that you guys are able to solve for x from here, so I'm going to stop it at this part of the problem, but hope that helps clearing up how to get this problem started when you're given two fractions and you need to solve for x. So the next problem we're going to go to is in number 2, where we're going to solve by substitution in letter B. So substitution is exactly what it sounds like. So you're given two equations, right? And you need to take one equation, solve it for one of the variables, and plug it in, substitute it into the other equation. So in this situation, one of our equations is already solved for a variable. It's already solved for y. So that means we plug in what y is equal to into y in the other equation. So what this means is the first equation is now going to look like 3x minus, now I'm going to plug in y, what y is equal to in the second equation for y in the first equation. So that is 4x minus 11, and that is equal to 10, okay? So now, since there's a subtraction sign, I need to distribute that subtraction to everything inside the parentheses, to this 4x and this minus 11. So this is now going to be rewritten as 3x minus 4x plus 11 equals 10. If you want to pause the video and solve for x on your own, and then I will keep going, and then you can check yourself. So you should have gotten x equals 1 for your first solution, and so now we still need to find out what y is. So now you want to plug in this x value in for x into one of the equations. It's easiest to plug it in for the equation that is already solved for y, since that's what we need to find. So now we have y equals 4 times 1 minus 11. So y equals 4 minus 11. Y equals negative 7. So our final answer for 2b is 1 comma negative 7. And the important thing to do next is to check your work. So how we're going to do that is plug back into the equation. So you can do that yourself and see if 1 negative 7 works for this problem. And I've already done this and it does work. So we know that this is the correct answer. And that is our solution for those systems of equations. So now I'm going to do 2D, talking with and dealing with inequalities. And so if you want to go ahead and do the other problems on this sheet, they're on number 2. Feel free to pause and work on that. But I'm going to work on 2D now. So first thing we need to do is solve each inequality for y so that it's written in slope-intercept form. So 2x plus y is greater than 3. Let's see, I'm going to move over here to have some more room. So that can be rewritten. I need to subtract 2x from both sides. And so I'm left with y is greater than negative 2x plus 3. And then when I solve the other one and put it in slope-intercept form, you can pause to do it yourself. And you will be left with y is greater than or equal to x minus 7. Okay, and that sign flips from less than or equal to greater than or equal to because we divided by a negative. Okay, if you have a question on that, you can ask in class tomorrow. So now the next thing I need to do is graph these two equations. So I'm going to have my first equation, I'm going to graph it in a green line, and then the other one I'm going to graph with blue. Okay, so my first equation, y-intercept at 3, so that's where we're starting, is at 3, at 0, 3, and then our slope is negative 2, so I'm going down 2 to the right 1, down 2 to the right 1, to the right 1, keep doing that. And then when I run out of space, I'm going to go up and to the left, up and to the left, up and to the left. And so this inequality is greater than. So that means it is a dotted line. Okay, so now that I have my line, I need to find out which side to shade. So we need to find a test point. So I am going to use the test point of 0, 0. In my opinion, that is the easiest point to pick with getting to choose which side to shade. So I'm going to choose this point right here, 0, 0, the origin. And so when I plug that in to the first equation, I get 0 is greater than 0 plus 3, because negative 2 times 0 is 0. 0 is greater than 3, which is not true. So that means I am going to shade the other side of the graph. Since 0, 0 is on the left side, I'm going to shade the right side. Awesome. So, okay, graphed the first inequality. Now I need to graph the second inequality. So I need to start down at 0, negative 7, since that is my y-intercept, and I have a slope of 1. So I am graphing my slope of 1, up 1 to the right 1, up 1 to the right 1, down to the left, down to the left. And then this is greater than or equal to, so I am drawing a solid line here. And I'm going to use the same test point of 0, 0. And so this would be 0 is greater than or equal to 0 minus 7. 0 is greater than or equal to negative 7. It is greater than or equal to negative 7. So that means I am going to shade the part that includes that test point. Since that's a true statement, I am going to shade this side of the graph. So now this means that my solution and answer to this system of inequalities is the overlapped part. So that would be this section right here where it's both green and blue. That is the solution to my system. So awesome. Okay, so I think you guys really understand and know your properties of equality and how to go from step to step. So I'm not going to explain number 3 or walk through that one. If you need help with that one, please ask during class tomorrow. But I am going to work through these word problems. So let's look at number 4. I'm going to highlight on here, and I think I'm going to need more room, so I'm going to go to a note sheet and work the problem out somewhere else. So I'm going to read the problem and then go back and highlight what's important and what I notice about it. So number 4, it says several students won a raffle and all got the same prizes. There was a stack of hats that the students split evenly and everybody got 3 t-shirts. If every student won a total of 5 prizes, write an equation that could be used to find out how many hats each of them won. Okay, so the first thing I like to do when I'm looking at a word problem is, what is the goal of this problem? What am I trying to find? So that's what this last sentence is saying. So I have to write an equation that could be used to find how many hats each of them won. So the variable that I need to find and solve for is the number of hats. So I'm going to go ahead and define x as the number of hats because I know that's what I need to find and solve for in this problem. Okay, so now I'm going to go back and highlight things that I think are going to be important as we work through this problem. So several students won a raffle and all got the same prizes. There was a stack of hats that the students split evenly. I feel like we might need that. And everybody got 3 t-shirts. Every student also won a total of 5 prizes. Write an equation that could be used to find out how many hats each of them won. Okay, so there was a total of hats, right? Total number of hats, that's our x. So that stack of hats was split evenly amongst the students, right? And so this x is being split amongst several students. Now we don't know how many this several students is, so I'm actually going to define another variable. That's the number of students, because the total number of hats has to be divided by the total number of students because they were split evenly. Okay, and then everyone also got 3 t-shirts. So that's just our constant, everyone got 3. And every student won a total of 5 prizes. So this equation shows us that the total number of hats that were in the raffle were split evenly. That's what division tells us to do, is it splits evenly amongst all of the students within the raffle. And then every student also got 3 t-shirts, and everyone got a total of 5 prizes. So this is the equation that would be written to find out how many hats each of them won. So there you go. Hope that helps with number 4. If you have any other questions, again, please ask in class tomorrow. Okay, so number 5. This I see, okay, looking at it at first glance, I see percents, I see money. So, okay, let's see. I'm going to read it once and then go back and highlight. So, a server at a restaurant takes home 68% of their salary after taxes and splits their tips 50-50 with the rest of the staff. They took home $1,250 last month between salary and tips. Write an equation using X for salary and Y for tips that could represent how much money they made last month. Okay, so the cool thing is, so the goal of this problem, again, we're writing an equation, and it already tells us what X and Y need to be. So X is salary, Y is for tips. So I'm going to go ahead and write that down. Write it over here this time. So we have X is the salary, and Y is the tips. Okay, cool. So, and this is going to represent how much money they made. So we know that all of this needs to equal an amount of money. Okay, so I'm going to go back and read it again. So a server at a restaurant takes home 68% of their salary after taxes and splits their tips 50-50 with the rest of the staff. They took home $1,250 last month between salary and tips. And then we have our goal. Okay, so I see some numbers that are associated with certain variables. I see the 68% is paired with salary, and this idea of 50-50. When I think of 50-50, I think split in half. Their tips are split evenly, 50-50. Everyone gets half with the rest of the staff, okay? And so this idea of half goes with tips, 68% goes with salary, and then we have this total amount of money. The thing is we have a lot of different units going on in this problem. We have a percent, we have a fraction, we have money. The money is okay. We can leave the money as is, and we're actually going to set this equation equal to $1,250 because that's what we're trying to write the first half of the equation that could represent this total amount that they made last month. So if we have 68% of their salary, and salary is X, and then we know that this total amount is equal to this percentage plus half of the tips. So half of Y. Okay? So the best unit that's going to be able to represent both percent and fraction like this is going to be a decimal. And so to have both of these represent decimals, we need to convert both of them into decimals. So 68% written as a decimal is going to be 0.68x plus, and then half written as a decimal is 0.5. Y equals 1,250. So this is your equation for this problem. If you have any questions on this, please ask during class tomorrow, but I hope that explanation helped think through logically which number goes with which variable and everything. Okay, number 6. So Daryl gets paid $50 a week, but also gets paid $40 for every pair of shoes he sells. Write an equation that could represent how much money he makes in a week. Okay, so again, goal. First thing, the goal of this is to write an equation, and it wants to represent how much money he makes in a week. Okay, so we need to think of what X and Y are going to equal and represent in our equation. So it would make sense if Y would be our goal. Y is going to be the total amount of money he makes in a week. I'm just going to say total amount of money, okay? X, now let's go back and read this problem again. So Daryl gets paid $50 a week. That makes it sound like no matter what he does and how much work he does, that is a flat rate. That's how much he makes every week, doesn't change. Okay, so that's going to be important, but we're going to use that a little later. But he also gets paid $40 for every pair of shoes that he sells. So guys, whenever you see the word for every or per or something that's linked to how many of something that you're selling or you're doing, that is where you want to think about like your rate of change or your slope, if you will, in a problem. And so if he gets $40 for every pair of shoes, X needs to equal the number of pairs of shoes he sells. Okay? And so this $50 a week doesn't change. No, he could sell 0 shoes that week and still make $50. So the total amount of money he's going to make is going to be $40 times the amount of pairs of shoes he sells plus $50. Because no matter how many pairs of shoes he sells, he will make that $50. So if X were to be 0 and he sells no shoes, he makes $50. If he sells 1 pair of shoes, he makes $90. If he sells 2 pairs of shoes, he makes $130. So that is how you write that equation to represent how much money he makes in a week. Again, questions, come to class with your questions. Number 7, I am not going to do, because you guys know how to see if a point works for a equation, or in this case, an inequality, so you guys can work on that one yourself. I will go over number 8 though. So this one says, Brad and Janet are saving money for the prom. Brad's savings can be modeled by the equation. I'm going to highlight y equals 25x plus 62. Janet's savings can be modeled by the following chart. And then we see the number of weeks and the amount of money she made each week, or she saved each week. Okay, so then there are questions. Who will have more money saved up at the end of 8 weeks? Show work to justify your answer. Then who has the greater rate of change? Okay, so again, this kind of is similar to the one with percentages and fractions in the way that we have two equations that are being represented in two different ways. One is being shown in a equation, and the other is being shown as a table. And the best way to compare them is to be able to have them both as one, to either have both of them as tables or both of them as equations. In my opinion, the table is very easy to change into an equation, so that is how we're going to solve this problem, is to change this table into an equation. So the important thing is, okay, so if we think about what an equation is, we have our y equals 25x plus 62. So that means Brad, I'm going to put a B by this one to show that that's Brad's savings, and then the J is for Janet's savings. And so the $62 is how much money he saved at 0 weeks. At the very beginning of all of this, he had $62 saved, okay? And then that $25 is going to be how much he saved each week moving forward, okay? So if we look at that and think about that logically, we can think the same way about Janet's, okay? So the first thing we need to think about is how much change happened between each week. How much did she save week to week? So from week 0 to week 1, she saved $31. From week 1 to week 2, $31. Week 2 to week 3, $31, and again, $31. So this shows us that Janet's weekly savings that she made, her rate of change, is $31, okay? So Janet's equation is going to be y equals 31x, but what is hers won't be 62. What would her starting number be? Well, that would be how much she saved at week 0, and so that would be her 37. So we need to add 37 at the end of her. So these are the two equations we see, is y equals 25x plus 62, which is Brad's saving money for prom, and Janet's is 31x plus 37. So now we can answer the questions that we have. So who will have more money saved up at the end of 8 weeks? Well, in our table, we can clearly see weeks is x and the amount of money is y. And so if we see weeks, 8 weeks, that means we need to plug in 8 for our x into each equation. So for Brad's equation, we have y equals 25 times 8 plus 62. And for Janet's, we have y equals 31 times 8 plus 37. So when I solve both of those, I get y equals 262. Oopsie, I wanted to do that in blue. Y equals 262, and this one will be 240. I meant to change to green again, sorry guys. 248 plus 37 is gonna be 285. So who had more money saved at the end of the 8 weeks? That answer is going to be Janet, since her total amount was greater than Brad's total amount. So then the next question, who has the greater rate of change? Well, what did we just say? Rate of change is how much they saved week to week. So that means we're looking at this 31 and this 25. Well, who had a greater rate of change? Again, that is going to be Janet. That's not always true that who's going to have more money saved at the end of the 8 weeks and the rate of change is going to be the same answer. That just happens to be the case in this problem. Okay, so another word problem. I know you guys love word problems, which is why I'm spending so much time on them and explaining them. Number 9 says a catering company charges $30 for setup, then $1.25 for every slider served. A second company charges $25 for setup, then $1.50 for every slider served. How many sliders do you need to buy for both companies to cost the same? Okay, cool. So first question to think about with this problem is the goal. What do you need to find? You need to find the amount of sliders. How many sliders do you need to buy from both companies to cost the same. So when I think of same, I think of equal. Okay, so when I think of equal, I think of intersect. When we worked with systems of equations where the equations equaled each other was that one point where they intersected, right? That was the solution. So that's how I look at this problem, and I see that we're working with a system of equations, okay? And so I want to write an equation for this first company, okay? So the x, let's first define our variables. So we have x and y, okay? So y is going to be our total for what? So the total amount of money spent at that company. So total money. Oopsie. And then x is going to be, I'll let you think for a second what you think x is going to be. Pause if you want. Is going to be the number of sliders served. Okay? And so now that we know those two variables, we can write an equation for each catering company. So for this first one, I'm going to do some color coding again. So for this first company, we have a $30 setup and then $1.25 for every slider served. So remember what I said, for each, for every, per, that is the term that's going to be paired with your x variable, okay, because it's the 125 each, right? So y is going to equal this 125x, and then $30 is how much the company charges no matter how many sliders are served. So when x is 0, that's how much it costs. So that would be our first equation, and then the second company is going to be charges $25 for setup, then $1.50 for every slider served. And so that equation will be written as y equals 150x plus 25. Okay? If you want to pause and try to solve the rest of this problem on your own, please feel free to do so. So this one's saying, how many sliders do you need to buy from both companies to cost the same? So our goal is to find out x, to solve for x. And since both of these equations are equal y, we can set both of these equations equal to each other. So what that means is I can have 150x plus 25 equal to 125x plus 30. Because since they're both equal to y, these equations are equal to each other. Okay, so then solving for x, you guys learned this last unit. I'm not going to walk through the steps here. So x is going to equal 5 divided by 0.25, which is equal to 20. So this means that you have to sell 20 sliders. Sorry, you need to buy 20 sliders from both companies for it to cost the same amount for the setup and for the sliders and everything. So in context, 20 sliders would be your answer to the question of how many sliders do you need to buy. So again, if you have questions, come to class, but hope that helps. So number 10, you are on a farm that raises cows and chickens. If there are 20 animals total and the animals have 56 legs in total, assume a standard number of legs for the animals. How many cows and how many chickens are there? Okay, this is kind of funny. So again, let's start with the goal. So the goal is number of cows and number of chickens. So those are going to be our two variables. So you can choose however if you wanted. They both start with C, so it probably wouldn't be good to use other letters besides X and Y. I'm going to say X is my number of cows and Y is going to be my number of chickens. And you might be wondering, how did I know that I needed to set up a system of equations? And that's because I saw two types of variables that I need to find a relationship between. And so that's how I thought through this. It's not about greater than or equal to. or an arithmetic sequence. We're not counting legs or animals are changing. They have a common difference between them. I see cows, chickens. I need to see how many there are in total when I'm not told exactly how many there are. So hope that helps you guys think through how you would find out what type of word problem you're working with. So then I'm going to go back through the problem and see what's important. And so there are, so you are on a farm raising cows and chickens, 20 animals total. So that means the number of cows plus the number of chickens equals the total number of animals, 20. We don't know how many of each, but we know all of them together will equal 20. Okay, and then we know that the number, here I'm going to do, instead we're going to do this equation in green. So you can see, yeah, x plus y equals 20. And then we have the animals have 56 legs in total. Okay, everyone has the number of legs that they're supposed to. So if you picture a cow and picture a chicken, in case you didn't know, cows have 4 legs, chickens have 2 legs, okay? So that means every one cow, there are 4 legs for each cow and 2 legs for each chicken. So that means 4 legs for each cow plus 2 legs for each chicken equals 56. That's going to tell me how many legs there are in total. Okay? So I'm not going to go ahead and solve this one because at this point you guys know how to, you can choose, when you're given a word problem, you can choose how to solve the system. These are the 2 equations you need, and you can choose to solve by substitution, by elimination. If you want to graph it, feel free. I would definitely recommend substitution or elimination. Either one is great in this situation, but I hope this helps you set up the equations this way to know how to keep moving forward. So, okay, so those are the word problems for the most part. There's a few more at the bottom, so let's keep rolling. You guys did problems like number 11 last unit. I'll do 11b just as a refresher. So to solve the following equations for the requested variable. So, okay, so we have this equation and it wants us to solve for L. So when it wants us to solve for a certain variable, that means we need to isolate that variable. So first, let's work with this 2. We need to distribute this 2 to everything inside the parentheses. So we have P equals 2L plus 2W. We need to get L by itself. So we need to, subtract 2W from both sides. And then we have P minus 2W equals 2L. And then we need to divide by 2. Everything by 2. Okay, and then we have L equals P minus 2W all over 2. And that's it. Nothing crazy. That is your answer. Again, come to class with questions if you need help on that one. Okay, let's do, I just want to talk about number 12 really quick. I don't want to solve it, but I want to look at this question. So we have this equation, g of x equals 12x minus 19. And it says it can be used to determine how many cookies a chef can bake in an hour. If you were solving for g of x, would it make sense for your answer to have decimals? What about negative numbers? Why or why not? So this one really makes you have to think logically and what makes sense in the context of this problem, okay? And so think about it. If you are baking cookies, you either bake the cookie or you don't. There's no kind of baked. I know there's that ice cream called half-baked. I really love that. You might too. But with cookies, they're either baked or not baked. There's no in between, okay? So it wouldn't make sense for you to have decimals because the cookie's either done or not, okay? You either baked the cookie in an hour or you didn't bake the cookie in an hour. And again, you can't bake negative cookies. You can't have less than 0 cookies baked. So it doesn't make sense for you to have decimals, and it doesn't make sense for you to have negative numbers. This is not sufficient for you to turn in, just writing no. You need to explain why or why not. You can take what I've said and write that into words, write it in your own words, what have you. So, great. Okay, so we have worked on characteristics of linears for the past day and a half or so. So, hopefully you guys have worked on the 2.9 homework and have gotten to ask questions during class about domain, range, y-intercept, increasing, decreasing, and behavior. So I'm not going to spend time on this one. If you have a question, please come to class with that. And we are going to work on 16 and 17. So this is talking about converting the sequences between explicit and recursive formula. So recursive formula, all that means is that it's written in terms of the previous term. That's why you see this n-1 here. That doesn't look great. The n-1 means the term that comes right before the term you're looking for, okay? And so the general form for the explicit formula, and remember guys that the EOC gives you the general form for the explicit formula, so you will be given the explicit formula on your test as well. So explicit formula is going to be a sub n equals a sub 1 plus d times n-1, remember? And then the recursive formula, what I meant a second ago about how it's not the most helpful because what you actually need to solve it is the term before it. So what I mean by that is a sub n equals a sub n-1 plus the common difference. So it's not the most helpful, my opinion, but we use it in coding and other things in the real world, which is why we talk about it for a second in here. I'm going to write the recursive in green just so you guys can see the difference. Okay, so if we need to write a sub n equals 7n minus 11 as the recursive formula, we need to find the term, we need to find the common difference, right? Because all of this, a sub n equals a sub n-1, that's going to stay the same. We just need to find what d is. So how we do that is you think about, okay, you want to plug in terms for n and find what that common difference is. So if you plug in 1 for n, you get a sub 1 equals 7 times 1 minus 11, and you get a sub 1 equals negative 4, okay? If you plug in 2 for n, if you plug in 2 for n, you get a sub 2 equals 14 minus 11, which is 3. If you do a sub 3, you're going to get 10. So you can see from here that the common difference from term to term is 7. Okay? And so your common difference, so how you're going to write this recursive equation formula is going to be a sub n equals the previous term plus 7. Okay? If you have questions on this, come to class with your questions. Kind of straightforward. All you have to do is plug in the common difference. And do that by finding first, second, third term, and then find out what goes between them. And then, so now we're going from recursive to explicit. So the important things we need for the explicit formula are a sub 1 and d, right? That's what we see here and here, right? And so it actually already gives us a sub 1 in this one, which is 6. So we just need to find what d is. Well, if we remember from what we just did with what the recursive formula is, whatever is being added on the end is your common difference. So that means this minus 4 here is your common difference. So your common difference equals negative 4. So you need to rewrite your explicit formula with everything plugged in. So a sub n equals a sub 1, 6, plus, or in this case, minus, since our common difference is negative, minus 4 times n minus 1. And don't forget, we're always simplifying. So a sub n equals 6 minus 4n plus 4. A sub n equals negative 4n. n plus 10. Okay, so this is your final answer in this problem, and this is your final answer in this problem. Again, ask questions in class tomorrow if you would like another example of this, but it's pretty straightforward. Okay, and then the last one, again, I'm just going to explain this one. I'm not going to really write this down, but just talk this through with you guys. So it says if f of x equals 4x plus 19 and g of x equals 6x plus 35, then what is the solution to f of x equals g of x? Well, this is really similar to the one we worked on earlier where they were equal to each other, the sliders problem that we saw, because we had to see when they cost the same amount. So this is the same thing where your outputs, your f of x and your g of x are equal to each other. So you would set this one up as 4x plus 19 equals 6x plus 35. And then solve for x, and that is your solution. So guys, hope this is helpful. Please come to class with these problems at least completed and with any questions on the ones that I did not go over. And if you still have questions on the ones I did, come to class with those.